Good evening all. Today we shall see the line supports in our third module. Supporting structures are used for supporting the conductors in transmission as well as distribution system. The line supports should have the following properties. High mechanical strength to withstand the weight of conductors and wind, loads, insulators, etc. They should be light in weight without the loss of mechanical strength. They should be cheap in cost and economical to maintain. They should have longer life. Then they should be easily accessible for the maintenance of conductors. They should be good looking, low maintenance cost. And types of line supports. There are different types of materials used for line supports. First of all, wooden poles made up of wood. Then reinforced concrete poles, steel poles, latticed steel towers. First we shall see wooden poles. These are made of seasoned wood and are suitable for lines of moderate cross-sectional area and of relatively shorter spans, say up to 50 meters. Such supports are cheap, easily available, provide insulating properties, and therefore are widely used for distribution purposes in rural areas. The wooden poles generally tend to rot below the ground level, causing foundation failure. In order to prevent this, the portion of the pole below the ground level is impregnated with preservative compounds like creosote oil. Double pole structure of the A or H type are often used to obtain a higher transfer strength than single poles. This is the A section as well as this is the H section. So it is a wooden pole made up of wood. Then there are cross arms on which the insulators are placed through which the conductors are being driven. The main disadvantage of wooden supports are tendency to rot below the ground level, then comparatively smaller life 20 to 25 years. Cannot be used for voltages higher than 20 kV. Less mechanical strength, then they require periodic inspection. The next type of poles is steel pole. The steel poles are often used as a substitute for wooden poles. They possess greater mechanical strength, longer life, and permit longer spans. That is from 50 to 80 meters. Such poles are generally used for distribution purpose in cities. Their average lifespan is about 40 years. So this is the photograph of steel poles used for transportation, for power transportation purpose. You can see the close arm on which the insulators will be placed through which the conductors are being driven. This type of supports need to be galvanized or painted in order to prolong its life. The steel poles are of three types: rail poles, tubular poles, and rolled steel joints. These types of poles are costly. Steel poles are costly. They are set in concrete at the foundation in order to protect them from chemical action. Below the ground level, the concrete may get damaged. So, in order to protect that, concrete foundation is being provided. And third type is RCC poles, reinforced concrete poles. They have become very popular as line supports in recent years. They have greater mechanical strength, longer life, and permit longer spans than steel. They can go from 80 meters to 200 meters. Moreover, they give good outlook, require little maintenance, and have good insulating properties. This is the diagram of concrete poles. We can have single circuit as well as double circuit lines along with this concrete structures. These poles are of two types: One is of square cross section from bottom to top, but sides of the square decreasing from bottom to top. Other type has rectangular bottom and square top with rectangular holes on it. The holes in the poles facilitate climbing of the poles and at the same time reduce the weight of the line support. The main difficulty with the use of these poles is the high cost of transport owing to their high heavy weight. Therefore, such poles are often manufactured at the site in order to avoid heavy cost of transportation. The last one is the steel towers. In practice, wooden, steel and reinforced concrete poles are used for distribution purposes at low voltages, say up to 11 kV. However, for long distance transmission at higher voltage, steel towers are invariably employed. They have greater mechanical strength, longer life, and can withstand more severe climatic conditions and permit the use of longer spans. The risk of interrupted service due to broken or punctured insulation is considerably reduced owing to longer spans. Tower footings are usually grounded by driving rods into the earth. This minimizes the lightning troubles as each tower acts as lightning conductor. This is the example of steel tower. We can have single circuit as well as double circuit provided on either side. So these are the different types of support structures used for power transfer. So we shall stop here. We'll continue with a new topic in the next class. Thank you.